Hello and welcome to week 4. So, so far, how did you all find the week 4 content?
Yes, it was good, ma'am. Basically, I'm from star background, so for me it was
It was
basics.
easy.
Yes, ma'am.
Great, great. So that's actually the fun part, for people who have some idea. This is like the easiest week amongst all 12, and even the questions are on easier side. But for benefit of everyone, we'll just go through the content of this week. So if you watch the lectures carefully, there's nothing more or nothing extra to understand, but simple representations or simple charts have been explained. And there are many. Oh, you're finding box plot confusing? Okay, no worries. I think the next slide is of box plots. We'll just revise box plots once, and maybe after that there'll be some clarity for box plots, right? So easy to most easy ways to represent any data. So before we go to that, do you all remember that different types of analytics we did in week 1? There was descriptive analytics, diagnostic analytics, then predictive analytics, and prescriptive analytics. So we had learned that in descriptive analytics, what we do is what has happened. So, in order to show what has happened, we need to have some visual representation, or we need to understand what type of data we need to show. And then, to simplify that purpose, there are different visualizations. So, now we'll quickly see what different visualizations kind of we can use and for what purposes we can use them. Yeah? So, bar chart is generally used for same variable in different context. Context is generally on x or on y-axis, and on x-axis the same variable we are putting it. So right now different types of sports are mentioned here on the x-axis compared to how many number of students have enrolled for that particular course. Yeah. So similar types, similar categories, and what is data, what is number of students, so that we are plotting here. Huh? So the same variable becomes this number of students, and this is the different context, different types of sport. Yeah. So very simple way this we have been doing, I think, from primary school, how we are representing data, different types of like this is how we learn reading the data tables and converting those data tables into different visualizations or representation of data, right? And pie chart is to represent how whole sample is divided. So when you want to kind of display part to whole relation, like out of the whole pie how much portion is going to a particular category, so such type of visualizations are very well depicted using pie chart. Hmm. So generally pie chart is also you can remember as part to whole representation of data. So nextly, histogram. So histogram mainly used for giving the distribution of data points across the range, the entire permissible range. So these are marks out of 30. So this histogram is actually used for marks of students out of 30. So what we did is we divided entire range into different bins of 5 marks each, starting from 0 to pi, then 5 to 10, 10 to 15, 15 to 20, and so on till 30. And now we calculated in each of the bin how many students are there, and came up with this table. And now we plotted for every bin for this interval what is the frequency, what is the count of students which are occurring in that particular range. So that gives us this histogram. Hmm? So histogram will tell us about distribution of sample, right? So whether it is what other information it can give is about distribution, such as skewness, whether it is left skewed or right skewed, on which end a particular majority of students are lying of this range. So that skewness. Apart from that, it can also, not very clearly, but sometimes, uh, sorry, outliers sometimes, okay, not always, only when there are one or two, and in rest of the bin it is high number. Yeah? So real skewness is like this, you can say the distribution for this particular curve. Yeah. So similarly, if the bins are plotted like this, then it will be, the distribution will go like this. So that means more number of students are lying towards left hand side of the curve, the bell curve or the histogram. So that means this particular sample is left skewed. If it would have been like this, then it would have been, more number of students on right side, right? So this would have been right skewed, and this would have been left skewed. So these are the concepts related to distribution of your sample across the range. Yeah? So no such questions will be asked, so don't get confused. If you're not understanding, just leave that concept there. Okay, no questions will be asked related to skewness or distribution of your sample. These all words are just good to know. Okay, so now, oh my god, ignore this title. I just modify previous week's PDF, so sometimes such mistakes are bound to happen. These are not performance matrix. This is about box plots. Okay, so box plot is one image or one visualization, one chart. It is also known as whiskers chart. So box and whiskers. So this gives so much of information about how our data is data distribution in entire range. Then what is the median? Median is the number which occurs most number of times. So for example, there are out of 50 students, 10 students scored 50 marks. So that means 50 would be median, because it is 10 students have scored 50. The associated value is, marks value is 50. And 9 students scored, not 9, let's do 8. 8 students scored 40, and so on. But then which number occurs maximum number of times as our x and y value? So x would be roll number, which would be independent variable, and dependent variable will be number of marks or the score of students. So in that score, which number occurs maximum number of times, that would be the median. So for box plot, we need information such as minimum value, maximum value, interquartile range. So what is this is 25th percentile mane 20, if we have sample size of 100 students, say for sake of simplicity we will do 100 students. Just remove this. So that means, and if we arrange them in based on their marks, ascending order of marks, then top 25%, where that ends, how much marks, at how much marks that top 25, bottom 25 students are ending. Like say out of 30 marks, the bottom 25 students are scoring marks 40 below. So that means 25 percentile mark will occur at 40 marks, because 45 students have scored below 40. So Q1 or first quartile will occur at 40. Then Q2 is median, because from Q1 to Q2, from 41 to whatever median value, sorry, not mean, median value, between that there is another 25% or 25 students which have scored between this Q1 and Q2, and another 25% of students have scored between Q2 and Q3. So that means, in other words, students who have scored marks between Q1 and Q3 are 50% of the sample. Yeah, and these are the formulae to calculate maximum value and the minimum value. So what will be the Q1 value? If we subtract 1.5 minus IQR, IQR will be what? Q3 minus Q1. Interquartile range is Q3 minus Q1, and median is Q2. And maximum is, there should be plus sign here, Q3 plus 1.5 multiplied by interquartile range. And minimum value is Q1 minus 1.5 multiplied by interquartile range. Okay, and numbers which are, or the, from our sample, the data points which are occurring after maxima or beyond maxima, these are officially our outliers. And the data points which are below minima, these are also outliers. And it is a way of representing the most common box, like the 50% of the our sample, it occurs between this Q1 and Q3. Yeah, right now it may be sounding difficult to understand, difficult to interpret, but you have to kind of get to know that this point represents bottom 25%. So below here is all bottom 25% of the sample, and after this Q3, here are the top 25%, and in between Q1 and Q3 lies the 50% of the sample. So this also gives us distribution of our data points across the range. So what happens is, sometimes our data points are not confining to the range, and some value goes really large or really small. So how to make sure that that particular value is a outlier? Outlier is that, what is outlier? The number which is not falling within the normal range or the permissible range. I will not use word normal, but within the permissible range. So how to calculate that? What is permissible? So what is permissible is maximum value and minimum value. So quartile 1 value minus 1.5 into IQR, and quartile 3 value plus 1.5 into IQR. So this gives us the total range for distribution. Anything below minimum is an outlier, and anything above minimum is also an outlier. And this is how it is represented, the standard way to represent. So this box gives us where the 50% of our sample, the middle 50% of the sample is lying, and these are the whiskers which tells the top 10% and bottom 10%. And this is the limit. This standing line over here denotes the limit, permissible limit from minimum to maximum. So that, and these are called whiskers. So box and whiskers. And median could be anywhere, like here also, anywhere in the box. Yeah, it doesn't have to be exactly in the middle of the box. So this is how you can read box plot, and based on box plot, what you can infer is what is the median value, the value which is occurring the most number of times, what are the outliers in the sample, and where the bottom 50% or top 50%, bottom 25%, top 25%, middle 50%. So variety of combination of the sample distribution, that also we can infer from this box plot. Another simple graph is scatter plot. where we plot one variable on x-axis and one variable on y-axis, and we try to understand if there is any correlation between them, whether changing one value is influencing other value or not. Yeah, so this also helps us in determining correlation or relationship between two variables. So similarly, line charts are used to compare multiple variables within same graph, similar graph, right? So when you want to show multiple number of variables, how they are varying with respect to same unit, then we can use line charts. So right now, in this graph, they are using desktop, laptop, and tablet sale for a month, for every month, how that is going, how that is proceeding. So that is shown in the one graph only. We are giving information about the three variables. So that was about line chart. Now, important point, we will where to use which graph, right? So that thing depends on what type of data you already have, what data you have collected, so availability of data, and what information you want to convey. So whether you want to convey a gender wise comparison of students, male and female, how they are performing, or you want to convey how many students have scored, subject wise comparison. So depending on that, you will choose the visualization which is suitable for your research question, or what information you want to convey. So that depends on your research question, that depends on your data also, and plus, most importantly, your stakeholders to whom you are showing the data. So if you are showing the data to students, they will be interested in viewing different things. Whether you are showing data to the management person who is running the school, they would not be interested in the same type of data which students or teachers would be interested. So teachers would want to know question wise performance for a particular subject. So if I'm a subject teacher, I would want to know in which question student lost the maximum number of marks, so that we can revise that particular topic. But if I am a student, I'm just interested in overall distribution of the mark, who was the topper, who scored the highest, who scored the lowest. So I'm interested in that kind of information. But if I'm management person, and I'm management person and I want to run the school, then I will not care about this distribution of marks at all. I will be more interested in how much money is required to run the school, right? So that again depends on stakeholders, for whom you want to create that particular graph, for whom you want to show that particular graph or visualization. Okay, so now coming to where to use which type of graph. So bar chart or stacked bar chart are used when you want to compare different things. So compare different categories, the values in different categories, so that comes under comparison. Now distribution, we saw distribution about histogram and box plot. So I think line chart I have put here by mistake. Line chart doesn't give us information about distribution, so I'm going to strike this off. Okay, distribution is given by histogram and box plot. Then correlation is any type of relation, or how one variable influences other variable. So that type of this thing is called correlation of this variable. So correlation is shown by scatter plot and or line graph, whether with one line with values of one variable, how the other variable value is getting influenced. So likewise, line graph or stacked bar chart is also used, stacked column chart is also used to show the correlation. Okay, so Ria, are you still confused about box plots? It can be little confused because of the words they are using, but try to understand that it gives us information about how our data points are distributed across the range. So if we want to plot how much number of students have scored, so all these competitive exams, they work based on relative performance of students. That means even if you give gate exam or cat exam, it is they always say that I'm in top 99 percentile. So what does that mean is we are into when the distribution is plotted, The 99 percentile would be somewhere in the outlier outside maximum permissible value of this IQR. So in such cases, the box plot will give us information about where the top performers are, you know, or where the maximum number of students are scoring, what is the range in which maximum number of students are falling. Yeah, so I'm repeating box plot only, Shrija, if you're listening, I'm repeating the box plot only. That box plot is marks distribution for a given range. It's very simple, you have to keep this thing is in mind. Okay, so Q1 is first quartile, first so it is like bottom 25th percentile of students. So that means if we have 100 students, and if we arrange data of 100 students based on their marks in ascending order, so where the lowest 25 students will fall, so the marks of 25th student, so when we arrange that in ascending order, the top 25, that means the lowest number of marks, so which are the bottom 25 students, so their marks value, the 25th student mark value will give us quartile 1 or Q1 value. Now 25 students are out, what happens to next 25 students? In the same thing, when marks are arranged in ascending order, then what happens is next 25 students, so next 25 students, whenever that happens, the number of marks scored by him, that becomes our median value or Q2 or second quartile, and so on. So Q3 is again next 25%, and maximum value would be our Q4. So quartile, as the name suggests, is the quarter of the sample. Yeah. So in this, one quarter lies here, 25%. Next 25% is here. The next 25% here, and the next 25% here. So how does this give distribution? So this 25% students are in this range, somewhere from -3 to -1.25 or -3, etc. Yes, Q2 could be anywhere in this IQR range, not outside this box. Yeah, because box is where the middle 50% of the distribution falls. So Q2 would be anywhere in the box. Doesn't have to be in middle of the box always, it could be anywhere in the box, because we calculate Q2 value based on distribution, how many students are scoring this thing. Okay, how many students are falling into that range, the top 25% students. So it may happen that all 25 students have scored somewhere between 50 to 60, so this become just 10. Difference between Q1 and Q2, it becomes 10. And then next 25%, it would be between 60 to 80. So this difference between Q2 and Q3 is 60, 80, 20. So if that box is between 50 and 80, then that Q2 value will not be in the middle, right? So now I'm going to read the comments in the chat box. How to determine IQR percentage? See, it doesn't have to be it is independent of skewness, positive or negative skewness, it doesn't matter. The box is always middle 25%, this is always bottom 25%, this is always top 25% of the sample, and in this box of IQR it is middle 50%, right? And top 25% at the bottom side, and top 25% at the top side, and bottom 25% at the bottom side. So very easy to read, actually box plot is very easy to interpret, it is not complex. So you will find that the whole purpose of using visualization is to make it simple, because as you know, pen is mightier than sword, right? So when we are doing some research, when we are finding something, when we are proving our hypothesis with the help of data, we don't hold others at gunpoint and convince them of our results, right? So we write reports, we write research papers, and we publish it to the world, so world can read our findings, and they can understand what work we have done. So now the next idiom in English is that picture speaks 1,000 words. So instead of writing 1,000 words worth of report, we'll just put in one picture which will convey all the information. So similarly, this is a beautiful example. Box plot is a beautiful example which conveys so many things, minimum value, maximum value, what is the permissible range, or all the values including outliers. right? What are the values captured, then where the bottom 25%, the top 25%, and where the middle 50% sample is lying. So that means it is giving us information about the distribution also, and which value is occurring most number of times, so it is giving us median also. Yeah, so maximum number of information is given through one single graph using this box plot. So just try to understand how to interpret this graph. You will be able to answer all the questions. Okay, so now let's start with the questions. We have had enough discussion on this. So which of the following is true for a histogram or in a histogram? Okay, so it can be used for numerical type of data, can be used for numerical nominal and categorical types. Bin size should be equal, or bin size could be unequal. So I am just getting one answer. Please mark your answers in the chat box. Okay, I'll wait for a few more seconds. I just have 3 answers. Okay, there is no consistency in the answers given in the chat box. Okay. Okay, so I'll just read all the columns. Okay, 1, option 3, 1, 3, 4, 1, 3, 1, 4, and 2. Okay, so that means you're covering all the options. So let's read all the options and let's try to understand all the options. Okay, so we are talking about histogram. So histogram gives us information about distribution of our data points. So if you remember from this graph, histogram, what we do is we divide our range into intervals and we calculate how many samples are falling in that bin or in that range, and then we plot it. So what happens when this range or these bins are of unequal interval? So here 0 to 5, then 5 to 15, then 15 to 25, and then 25 to 30. If we do that, then it will not give us correct information about the distribution, right? If the bin size is unequal, it will not give us correct picture about this distribution. Here right now the information is correct because the bin size is same. Yes, somebody has raised the hand. You can unmute and talk. Pravida? Yeah.
Yes, ma'am. Actually, when the bin size is unequal, we can calculate the frequency density and plot the histogram. Which is not a popular method, but it is true actually.
Yeah, that's true. But right now we are not going into that complexity. I was about to clarify that even if that is correct, it will not give us the standard bell curve.
Okay, ma'am.
Right, I mean, you agree with me, na? It will not give us when unequal bin size. We can't plot this normal distribution bell curve. For that purpose, we have to go with equal bin size, right?
Yes, that's true. That's true.
So it will not give us the correct picture about distribution. We have to work on it to get to the correct picture of distribution. Right? Everybody agrees with me that bin size, unequal bin size is possible, but it will not give us correct information about the distribution of our sample. We'll have to, as Pravida ji pointed out, we'll have to work on unequal bin size to determine the actual distribution. Right? So it can be plotted, but it will not be giving us all the information through one single visualization, right? So we will not make our life complicated, and we will not go with this option, right? Even though it is possible, but we will not go with this. Okay, we'll go with this. Okay, let's keep it as simple as possible, because our readers, for whom, our stakeholders for whom we are creating these visualizations, they may not be well versed with the statistical concepts or with the with this part of converting unequal bin size into proper interpretable proper distribution. So to keep things simple and uncomplicated, we will choose the simplest form of visualization to convey the maximum information via one single picture. So that's the main motive actually behind introducing you all to different types of charts, is how you will decide which type of chart to use and how to plot those charts in a simplistic way, so that our stakeholders are gaining maximum information without the technical knowledge, without the technicalities of understanding that graph. So that's why we will go with option 3 and will not go with option 4. Okay? So option 1 and 2, now let's go, now let's read one by one. Only used for numerical type of data, and can be used for numerical, nominal, or categorical type. Okay, so this thing is uh, about the data for which we are putting the distribution, right? So here what we are doing is, we are actually continuous data we are capturing. Marks is a numerical value, right? But we are converting into intervals. That means we are creating categories, and then this is the distribution or frequency, right? So we are not plotting nominal data or numerical data or categorical data, but we are plotting the distribution. So we are converting numerical type into bins or categories. So that makes this option correct. And if we want to use it for complicated data types, then again we have to do a lot of pre-processing before we plot it. So for sake of simplicity, we will go with option 1 and option 3. Okay. Let me know if anyone has any other point to add, because we have one person with statistics background. So if I'm wrong, or if I'm giving some wrong information, please feel free to correct me, unmute and correct me then and there only. I think Pravida ji, you only are from statistics background, so if you see that I am not giving correct information, please feel free to correct me. And
Yes,
also,
ma'am. Sure, sure.
sure, yeah. So there's one question. Different bean size leads to different histogram. Um, Not really. The appearance of histogram will change, um, because the x-axis will not be equal interval, right? It will be like this, and then suddenly like this, and then suddenly like this. So yeah, I mean, I'm not sure if this is correct explanations, but Pravida ji, if you have concrete answer to this question, is different bean size lead to different histogram, then please feel free to add.
Ma'am, the histogram can be drawn with different bin sizes. Like you mentioned, I can take it from 10 to 20, or you can take it from 15 to 20. But only thing is, like, the conclusions may differ. So in order to keep the uniform conclusion, we keep the bin size as same. Like you
Right.
mentioned, for all of us, in a class, we keep the range from 5 to 10, 10 to 15, 15 to 20, like that. So there is no difference in the histogram as such, but the conclusions may change. Say, for example, I may be interpreting something like most of the students are between 10 to 15, and someone else may be interpreting like no, it is somewhere between 10 to 20. So in that case, both of us are correct. I am into 15 to 20, and they are into 10 to 20. So the
Right.
conclusions may differ. That's it.
Okay, okay. Yeah. So Ria, I hope you got your answer. Right? That was very nicely put by Prabida ma'am. Okay. In this case we are, see, in this case all the options are true, but which we will pick for sake of simplicity. We will not make things complicated. We don't want to be expert in all types of visualization and all types of analysis. What we will do is, we will try to make our visualization or our report writing as simple as possible. So visualizations come in handy when you want to design any dashboards. So in dashboards you will notice that the things are generally, the more inclination is towards making things simpler and not complicated. So keep this thing in mind, that whenever the questions regarding to this descriptive analytics or charts are coming, think from making things simpler and not making things complicated. So as we have discussed in detail, Pravida also mentioned how unequal bean size will make histogram will be there, the distribution chart will be there, it will look like a proper histogram only, it will not look something else. But we'll have to put in some extra efforts to interpret it if there are unequal bean sizes on x-axis. But if there are equal bin sizes on x-axis, whatever you are seeing with your eyes, that the same thing is getting inferred. You don't have to put in do some extra calculations to kind of make out where the student is lying, or where the top students, or where the bell curve is going to maximum height. So all that is actually uh, easier to interpret with equal bin size. Yeah, so all such questions we will answer from simplicity point of view, making things easier to interpret point of view. So from that point of view, 1 and 3 are correct. Okay, so here comes box plot. So consider following box plot. It represents distribution of marks in mid-semester exam. Now this is, they are assuming median value is 27.5, median or Q2 value. So they have not worded it properly, but this is what they mean. Okay, so dark vertical line is at 27.5 and it is median, because dark line in the middle is always the median. Now what is the approximate percentage of students having marks between this 27.5 and 31? So can you tell me what will be this point? This point will be minima or minimum. This will be maximum. This will be Q3, Q1 and Q2. Am I correct? And what is included in this box plot? What is other word or the main word for this thing? Interquartile range. Yeah, between the first quarter and the last quarter. That's why it is called IQR or interquartile range. So this is bottom 25% of the sample. This is this from here. This is, and arrow should be here. Yeah. This is top 25% of the sample, and within this box lies the 50% of the sample. So now again think about it. What is the percentage of students having marks between 27.5 and 31, between Q2 and Q3? I am getting answer is 25%, 25% and 50%. So if you want to change your answers, think about it. In this entire box, if this is 24, so between 24 and 31 lies the middle 50% of the sample. Yeah. So from this point to this point there lies 25% of the sample, and between Q1 and Q2 lies the 25% of the sample. So between 24 to 27.5, 25% students have scored marks, and between 27.5 to 31 there are 25% of the students. So those who have gotten answer as 50%, do you want to share how you came to that answer of 50%? Shreyan and Shrija. You can type in the chat box or you can unmute. Because Shreyan, you seem to have typed it after I was done explaining. You still think that answer is 50%. So I need to know where the misconception is lying with you. So please unmute and answer, because when I was done explaining, after that you have typed in 50%. Okay, since Shreyan and Shrija both don't want to answer, I think we'll move on, because unless we know where is confusion lying, we can't address it. Right? That's why we do diagnostic analysis. We understand why a particular thing has happened, and then we do prescriptive analytics, where we want to address that why cause, the root cause, what went wrong. So that's why this goes into loop, you understand. First we go descriptive analytics, we describe what has happened. So here how it is working as the answers which you have given in the chat box. I have seen how many of you think answer is 25%, how many of you think answer is 50%, and so on. So that is giving me an answer to what has happened. And then I could figure out, okay, there are two people who have said that the answer is 50%, which is not correct. So I'm trying to understand why they think the answer is 50%. So if they would have unmuted and told me that, okay, this was the logic behind choosing 50% as the answer, then we would have understood the diagnostic analytics part. Okay, what has gone wrong? Then we could have addressed the misconceptions through uh, by prescriptive analytics, and this is how we will get to optimize the learning environment to maximum benefit of everyone to achieving learning objective. Okay, so in day-to-day life, in classroom also, these analytics are happening, whether knowingly or unknowingly. We follow it like every day while teaching also, and as students also, that something is going on, so there is a descriptive analytics going on, you understand, you interpret, and then we try to correct. If we have some misconceptions, then we try to correct our model. Yeah. So I'm getting answer from both of them that, ma'am, actually I thought first 25%. Oh, no, 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 no. So that is yeah, so that's not true. In interquartile, the name suggests that the quarter range. Okay, so this is the bottom quarter and this is the top quarter. So between bottom quarter and top quarter lies the interquartile range. Okay, so the box represents the middle 50% of the sample. So when we say middle 50%, or the top 25%, or the bottom 25%, so all these are number of samples lying in that range. Okay, we are talking about distribution. Okay, so this is first 25, then next 25%, next 25%, and next 25%, and so on. Lies 25%, lies 27 and 30, and next 25%. So this is 24 na, and this is 31, and they are asking the question. In question they have asked, what is the range between 27.5 and 31? So now I am getting confused, that why are you getting confused? So in question it is clearly mentioned, not between 24. If they would have asked between 24 to 31, then 50% would have been correct. I just interpreted this question. Dark vertical line is always the median or Q2 value in the box plot. So this particular, they have not worded it properly, but I just interpreted that when they are asking about this, so this sentence kind of looks abrupt. Consider the dark vertical line denoted by Y lying in the box plot. We are considering, but consider it as what? So dark middle line is always the median value or Q2 value. That's the notation of box plot. Okay, so I kind of added that 27.5. Let's consider the dark vertical line value to be 27.5, and dark vertical line is always Q2. Okay, so Q2 or median. Then from that median value to the Q3 value, it is 1/4 of sample lies within that range, and Q1 value to Q2 or median value, 1/4 or 1 quartile value lies. So this is the interquartile range where the middle 50% of the sample lies, which is denoted by the box, by this box. So these are the standard notations of box plot. So this thick vertical dark line will be always Q2 from the visuals, and these are the whiskers. There would be a stopping line at the end of the whiskers. So this would be maximum on the higher end of the box plot, and this would be minima or minimum at the lower end of the box plot. Yeah, so this is how these are all the standard notations. This is minimum value. So if you have minimum value, you can calculate IQR, because minimum value and Q1 value is there with you. So minimum is Q1 minus 1.5 multiplied by IQR. So using this formula, you can calculate what is the IQR value. Okay, so this was the perfect example of how we used different analytics to optimize the learning environment for us. So Shreyan and Shrija, I hope there is no confusion now, and you guys are clear about how we are interpreting this box plot. Okay, so don't get confused with the standard notation. Yes, Ria?
Ma'am, can you please explain the formula?
Ria, there is a lot of background noise. I'm not able to understand what you're saying. Speak loudly.
Ma'am, can you please explain the formula about how to calculate median from this box plot? Is it between from Q1 to Q3, or from where I can calculate minimum or maximum?
We
Please
can.
explain the median formula.
There is no formula for median. Okay, so you have to understand there is no formula. There is median is the common value, the highest frequent value in the sample size. So there is no formula for median. जैसे एवरेज के लिए फॉर्मूला होता है, वी एड ऑल द सैम्पल्स एंड देन वी डिवाइड दैट एडिशन बाय नंबर ऑफ सैम्पल्स इन आवर n whatever number of data points in our sample. That's the average wala formula. But how these values are distributed, that we don't know. So there is no formula for median. Okay, so you have to understand this median or Q2, it doesn't have formula. Yeah, Pravida ji, if I'm wrong, yeah, please correct. Yeah.
Yes, ma'am. Actually, median is the middlemost
Middle one,
observation.
yeah.
Most frequently
That's mode.
observation is
Yeah,
mode. I
mode.
think by mistake you said
Yeah,
it.
yeah.
And for raw data, for ungrouped data, when like someone has already written that, we arrange the data in ascending or descending order, and we calculate the middlemost observation. Suppose that I have the observation 1, 2, 3, 4, 5. So it is already arranged 1. So the middlemost observation is 3, which means that 2 observations are below that observation and 2 observations are after 3. So 3 is the median value.
Yeah, I'm sorry, I got confused between mode and median. Sorry if that has led to confusion, Ria. Yeah, but I hope things are clear now how we are calculating median.
So for this, if we have the number of total sample is even number size, then in the middle center value we got we will calculate average number, right? For both two.
Yes, you are correct. You are correct, Ria. When we have even number of observations, say 1, 2, 3, 4, 5, 6, I have 2 numbers in the middle, right? So what we do is we calculate the average of the middlemost observation, say 3 and 4. So the average is 3.5. So median is just a positional average. Median might not be a member of the data set. So say for example, 3.5 is not a member of the data set. So it is a positional average. So like ma'am said, it is the 50th position what observation is happening, that is the median value.
Ria, anything else you want to clarify?
No,
Okay, so I have mentioned this minimum wala and maximum wala formula in the diagram itself. Yeah? I'm feeling bad that I've confused median and mode. Oh my god. Thank god you pointed it out before we are done with the session. Okay. I think we were done with question 2. Now question 3. Yeah. So question 3, to depict the visualization in dashboard, researcher can use different available charts or plots. For choosing the correct representational chart, which of the following statements are correct about visualization charts? Okay, so here again we'll have to keep this one thing in mind, that we are talking about simplifying the representation of our data to different stakeholders. So this visualization dashboard, everyone, including the people who will not have knowledge about statistics or who will not be very good at interpreting diagrams, so they also will be referring to these dashboards. So we'll have to choose the statements so that we are fine with um, the interpretation of the sentence has to be from that simplicity point of view. Okay, so let's I'm getting answers in the chat box, that's good, but let's just go through this options. Okay, a 3D pie chart do not provide any additional advantage as compared to 2D pie charts. There's agreement or disagreement about this statement. Do 3D pie chart provide some additional information over 2D pie charts, or it just makes thing like there is no addition advantage? They are just same. It is just the 2D picture or 3D picture with the illusion. So this seems to be true, right? Then histogram is generally used for quantitative data, whereas bar charts are good for qualitative data. Okay, so what do we mean by this? So what happens is, histogram we plot frequencies, how many in what quantity things are happening, right? And bar charts is within the same context, when we want to give different variables or different information, we want to compare and contrast, then we go for bar chart. So that is more of a qualitative analysis or based on qualitative data, right? So this is also correct when we are dealing with quantity and when we are dealing with qualitative data. Okay, then histogram is generally used for qualitative data, whereas bar charts are used for quantitative data. This is not correct, but if we want to plot qualitative data in a histogram, then we'll have to convert it into a categorical data, like continuous numerical values are there, then we have to make the bins, or in other words create categories and then plot the frequencies. So this also doesn't make sense. Then change in value of a variable best represented using a pie chart. Is it true? When you want to depict the change in value of a particular variable, then pie chart is the best, not the best available option there. When we want to plot the change in the variable, then we have the line chart or time series graph, so which will give us some information about what was the value before and now what it is, whereas pie chart gives us information of part to whole nature. Okay, so this is also wrong. So pie chart gives us value. So Riya, this is what I was talking about. So pie chart gives us value about part to whole. This is how the pie chart is, the whole 100%. And what is the, so this, let this be the class strength. Okay, total number of student in class. So how many girls and how many boys are actually in the class? So that means what proportion of the total class is for boys and what proportion is for girls. So when we want to represent change in the variable, we'll have to do multiple such pie charts, like over the week, what is the attendance in the class. So you cannot depict that over the week information in a single pie chart. That will not give us the correct information, whereas we want to see the gradual change in attendance. So that means we have to either come up with 6 different pie charts for every day of the week, or we can have one graph, line graph, where every day attendance is plotted, Monday, Tuesday, Thursday, Friday, and so on. Monday, Tuesday, Wednesday, Thursday, Friday, and so on. So likewise, we can use either one graph or we can have multiple pie charts. So which you think will lead to a simpler interpretation, one line graph or multiple pie chart? We can use any graph for anything, but whether you want to make things complicated or where you want to make things easier, depending on that you will choose. Because see, people will look at our image or our visualization and they will try to interpret the information. So whether you want to make their life easier by giving them picture instead of a 1 page or 2 page description of that data, So it's easier to have a look at one picture and then interpret that data. So the whole purpose of using visuals is to making things simple. So if our visualization is as complex as the text or even more complex than the text, then there is no use of putting it. So we can put in 10 different pie charts and show how girls attendance is varying and how boys attendance is varying. So trend will not be it's like if you want to plot the trend, pie chart is not the most suitable visualization. There are other graphs such as line graph and maybe bar chart. So that kind of visualizations are more suitable for trend type of data and not the pie chart. Pie chart will give us information about out of 100 how many boys, how many girls, out of 100 how many boys were present, how many girls were present, and so on. So change in the value will not be best depicted using pie chart. So moving on to next question. Dr. Arnab is a faculty at ITM. He wishes to visualize the difference in frequency of actions performed per week on LMS of male and female students. So we'll have what he wants to frequency of actions performed by male and female students across the semester. So what he wants to do is comparison study. So comparison study he wants to do for number of frequency of actions performed. So okay, I'm getting all correct answers in the chat box. So he wants to use the bar chart to give maximum like least complicated visualization. Easy to interpret visualization will be of bar chart. Maybe like this. This is boys and this is girls. Something like this. Number of actions performed in week 1, week 2 till week 12 of a semester. Girls and boys. Yeah? Either he can do simple or he can do stack. But bar chart will give better information. Now match the following. This I will give you some time. Bar chart, histogram, pie chart, scatter plot is on one column, and next column is correlation, part to whole, comparison and distribution. So bar chart is used for comparison, we just now saw. Then histogram, we can plot distribution. Then pie chart, part to whole type of information, scatter plot, correlation, or any scatter plot, correlation between the variables. So this brings us to option 2. Almost all the answers are correct in the chat box. Okay, so coming to question 6, which of the following statement are correct? Okay, so this is about box plot. So we'll read everything and then you can start giving in your answers. So interquartile range is difference between second quartile and the first quartile. So I will draw a box plot. This is minimum and this is maximum, and this is IQR. Okay, so now you have to tell me what this point will be called and what this point will be called, so that we can calculate the difference as IQR or interquartile range. Okay, so tell me if this first one is correct. So I'm getting almost all the options as option 3 and option 3, 3, 3, 3 and 4, 3 and 4. Okay. So first is not, nobody is saying first is answer. IQR is not the difference between second quartile and first quartile. Okay, cancel. Then interquartile range is difference between third quartile and second quartile. That is also not an answer. It is not difference between third and second. Option 3, interquartile range is difference between third quartile and first quartile. Yes, because this is Q3 and this is Q1. So difference between Q3 and Q1 is IQR. So this is correct option. Then median is equal to second quartile value. Yes, this is also correct. So 2 and 3. Yeah, first one is Q1 and the last one is Q3. Correct. This was Q1 and this is Q3. So option 3 is also correct and option 4 is also correct. Question 7. Which of the following statements are correct? So scatter plot shows relationship between two variables. True or false? When we want to, what is scatter plot is simply plotting x and y values. Likewise, yeah. So scatter plot gives us whether with the increase in variable x, what is the impact on variable y. That means we are understanding relationship between two variables. So this is correct. A scatter plot shows relationship between two variables. Then option 2, scatter plot is used to show distribution of numeric values. So will scatter plot give us any information about distribution of numeric value? Not really. No, because we are kind of plotting two variables together. So we will not be getting complete picture about distribution of any of the either of the variable, right? So because we are plotting them with like in relationship with other, like we are trying to find if there is any correlation. So that means this statement is wrong. Then line chart shows variation only with time, and line chart shows a variation of variable with any other parameter. So what do you think, whether when we want to do a line graph, so if I have this line graph, will x-axis always be time or it could be something else? Can this have something else, the x-axis value, or we can limit only it to time? For example, I have score value here. This one is for boys score and this one is for girls score of quiz 1, quiz 2 and quiz 3. I have 3 variables. So is this a line graph what I have drawn? Quiz 1, quiz 2 and quiz 3. Is it only with time, or we can plot legible graphs, interpretable graphs with variable other than time also? Yeah. So line charts are not limited to only showing time series data. We can show other variables also, other parameters also in the line graph. Okay. So option 4 is correct, but only with time is not correct. With time also it gives easy to interpret data. It shows us variation in the variable, how that variable is changing in the time. But we can have other variables also, not just limited to time. So likewise here there are quiz 1 score, quiz 2 score, quiz 3 score. This is not related to time. The sequence of quiz 1, quiz 2, quiz 3 we can change and still it will show variable topic wise marks. That comparison it can show. Now, instead of Q1, Q2, Q3 you can say quiz on topic 1, quiz on topic 3, quiz on topic 4 and so on. So even line chart, the other variable, one main variable and the other variable could be something beyond the time. No, could be something else as well. So question 8, which of the following statements are correct for bar chart. So Ria, line graph doesn't always show relationship between two or more variables. It can show changes in a variable with respect to other, like some like you remember that bar chart cup I had shown that when so line graph and bar chart are similar. Instead of bar, we just consider one point and then draw a line in that. So it will not show relationship between these two, but it will show for that category what was the value of the main variable. So that category means we had considered quiz 1, quiz 2, quiz 3. Similarly, semester 1, semester 2, semester 3, it could also be that. So for that particular value, what was the value of our main variable? So it doesn't have to be a relationship showing graph. It can show the value of one variable for different categories. Okay, so don't get confused between relationship between these two. Coming to question 8, next question. For bar charts, we have to.
Is it for scatter plot?
Sorry, you have some question to ask?
The relationship of two or more different variable, is it for scatter plot?
Yes, it is from scatter plot, where we consider both the values on axis, like x-axis and y-axis. X comma y, when we plot, we are considering values of both the variables. So that gives us pictorial representation. I think there's one question on scatter plot. So once we go to that, it will be more clear. Okay. So now let's come back to question 8, and once that scatter plot comes, we'll have discussion about display. Now bar charts. I'm getting couple of answers in the chat box. Bar charts are used to represent the correlation. So is this correct? Do they represent correlation? No. Correlation is scatter plot. Then the bars can be plotted vertically or horizontally. Vertical bars or horizontal bars. Both are correct. So this is correct. Then bar graphs, bar graphs are usually used to represent continuous data, and bar graphs used to represent categorical data, right? So which of these statements is correct? What is continuous data and what is categorical data? So continuous data is something like, for example, our height. It can have continuous value, numerical value. Even our score, number of marks which we are scoring. So when you want to plot the bar graph for continuous data, then we'll have so many bars, right? So if we are using bar graph to plot number of marks, we can plot score of every subject using bar graph. But for one subject, how many students had scored 10 marks, how many students had scored 20 marks, likewise we can plot. But 10, 20, like this, it will not make any sense, no? 10, 20, 30, 40, whatever. So it has to be some interpretable, some sensible information which we are plotting using graph. So in order to convert it into bar graph, like histogram, what we do is we change that continuous data into bins or range, and then we count number of students, the frequency in that, and then convert it into, or pictorially represent it as a bar chart also, no? So histogram is also one type of bar chart only, where we are plotting the range or the frequency in that particular bin as a bar graph. So this for continuous data, if you want to plot as bar chart, it becomes a histogram. So option 3 is not so correct, but categorical data, like here, this we can represent the data here from this graph. We can represent as bar chart also. We have different categories of quiz 1, quiz 2, quiz 3, and boys score and girls score. So we can represent same data here as quiz 1, quiz 2 and quiz 3, and this was the score. So we have categories of quiz 1, quiz 2, quiz 3, and then we are plotting the score here. Okay, so coming to question 9, we are done. Yeah, categorical data. Coming to question 9. What are the considerations you need to make when using a visualization technique? That means which visualization to use, and how to use, how to choose that, right? So what kind of information you want to convey? Yes, of course, we have to keep this thing in mind, what we want to tell. That will depend on our research question and the data which we have. So that brings to option 2, the kind of data you have. Yes, we have to take in account what type of data is available, and how we can convey, or how we can depict maximum information in a single visualization. Opinion of participants in your study, not so much. What is their opinion? If that is not relevant for us, we will not be considering that. If that is not relevant ka matlab kya hai, what if that is important for our research questions, or the point which we are trying to investigate, or the point which we are trying to make across, what information you want to convey. If that information is not related to opinion of participants, then we will not consider that while making decision about which visualizations to use. And easy to interpret, yes, of course, that's the whole point of using visualizations in our analysis. So correct answer is option 1, option 2, and option 3. So 1, 2, and not option 3, option 4. 1, 2, and 4. Yeah, so this brings to scatter plot. Okay, so in this figure, what is the relationship between two variables? Yeah, so this is what I was talking about, Ria, when I was telling you. So this is the x variable and this is the y variable. Okay, so this particular point is, the x value is here x1, y value is y1. Similarly, for this particular value here, and y2, right? So each point we are plotting, as group of x and y together. X2 y2, x2 comma y2, and x1 comma y1. So we are considering both the variables together. That's how it gives us relationship between these variables. How change in x is impacting y, right? When you're increasing x, is y also increasing or y decreasing? What type of information you are getting? It cannot be more than 2, otherwise it will be 3D. For 2D, for 2 axis we can have 2 variables plotted in scatter plot. A third variable we can't show for 2-dimensional scatter plot. Okay, so this way we can have a relationship between the variables. What is impact when one of the variables is increased or decreased? How it impacts the other variable? So that information we can gain from this. Okay, so here this is the best fit line. So best fit through the sample is a straight line. That means there is a linear correlation or non-linear. So two types of correlations, linear or non-linear. So here, since there is a best fit line is a straight line, that means it's a linear correlation. This is a straight line, so linear correlation. Now what is positive, negative? Whether increasing one variable is also increasing another variable, dependent variable value is also increasing, that means it is positively impacting. But if independent variable value is getting decreased, and that is resulting into increment of dependent variable, that means there is a negative correlation. If one is increased, the other one get decreased, that is negative correlation. And if one is increased, the other one also increases, that's a positive correlation. So in this graph, can you tell me whether it is positive correlation or negative correlation? Yes, very nice. This is positive correlation, because with increase in x value, the y value is also increasing. The straight line is going up, it is not coming down. Yeah, so there's a positive correlation. Yeah, so highly positive or highly negative will depend on how this best fit line is there. So this is highly positive. Now just highly positive will be this, positive will be this is also positive. We are increasing x value, and y value is also increasing, right? But this is highly positive, little increase in x value is resulting into significant increase in y value, right? So that's highly positive. And similarly, this is negative, this is positive. And if the data goes like this, then what type of relationship will this be? Non-linear, correct. Yeah. So that was about question 10. I'm going to take water break. If you have any questions or concerns, type in chat box or unmute and ask. Okay, so we need to why do we need to select positive correlation? Okay, relationship is linear, but increment in x value, x variable value, is also resulting in increment of y variable value, right? Here, as your x value is increasing, your y value is also increasing. So that means there is a positive relationship between them. When we are increasing one variable, if other variable is also increasing, that's a positive relationship. And if increment in one variable results in decrement in another variable, that's a negative correlation. But it is asking about relationship, no? What is the relationship between two variables? That means it is correlationship. Correlationship is nothing but relationship of these two variables with each other. That's the correlation. How these values are correlated. So relationship, correlation is same. This could have been asked, what is the correlation between these two variables? So that would also be correct. If line is curved, how do we input? So then it becomes non-linear, yeah? So remember I had shown this example, like this is x and this is y. Then what type of relationship will this be? There is a nice curve. It becomes non-linear relationship, because best fit line would be this. It will not be a straight line. So relationship is linear when the best fit line is straight like this. Here the red line. So that's a example of linear relationship. But if scatter plot looks like this, then it's a non-linear relationship. Yeah, so the correlation is non-linear in this case, and here the correlation is linear. Here it is linear. No, many of the times you will ask, these are called multiple selection questions, MSQ. So sometimes there are more than one options correct. So simple trick to know that is, when the single answer is correct, you will get radio button. This I think I had told in first lecture. Yeah, radio button like circle in front of options. Yeah, but if there are more than one options correct for a quiz question, there will be square. You need to select the square. So this is how you identify whether there is one answer correct or multiple answers correct. So we are using the drawback of CSS and HTML to our advantage to understand whether the question has single option correct or multiple option correct. When there are multiple option correct, they will not use radio button, they will use checkbox, square. And if there is a single option correct, they will use radio button, which is circle. So you try noticing this when you answer your assignment questions. You will understand how HTML works or CSS works. is that single option correct is always circle, multiple option is always square. So pay attention to what type of shape is in front of all the options. LXT is extension of learning activities. So that is something extra reading for you to understand the topic better. So no questions will be asked from LXT, but if you want to know more about the topic, if you want to have conceptual clarity about different topics, it is recommended that you go through LXTs. But the activities which are conducted in LXTs or the things which are covered in LXTs will not be actively asked in assignment questions. These are more for clarifying your concepts. Okay, one more announcement is, let me repaste it. I noticed that the folder link to the PDFs which I use for sessions is not shared with you all by NPTEL folks. So I just copied and kept the link handy and pinned, but sharing it again in case you are missing. So first link is to the Google Drive folder where I have uploaded week 1, week 2 and week 3 PDFs which I have used, and today's PDF also I will be uploading immediately after the session. And on this YouTube channel, which is the last link, you will find recordings of all the sessions. And since I have conducted such sessions last year also, so there are links to last to last year's assignment solving as well available there week wise. So if you want to take some extra help, or if you want to understand something, you can go through that as well. So this link I am sharing is for the folder, so you copy it once and all the week's PDFs will be stored in the same folder. So you will find all the folders here itself. Okay, so this is it. I've shared these links. If needed, I'm not putting these links onto forum, because then it will create confusion that there are already lecture PPTs and there are lecture videos, there are many other things, and into that this one thing gets added, and then people who are not attending these sessions, for them it will be confusing that what is this, if that is important, if they should know that. That's why I have not shared it in the forum, but instead sharing it to smaller group here, because you know what it means, you know the notations or whatever I am writing on the PDFs, so you know what does that mean. So you can use it for revision because you have already gone through it once. That's why not sharing with the bigger group, but sharing it with a smaller group. So if there are no more questions, we can end today's session early. Yeah. Oh, thank you, Pravida ma'am, for correcting when I was getting confused between mode and median. Thank you so much.
It's okay, ma'am. It happens with me also when we teach. That's okay.